Greetings and welcome, friends. Mr. Waddy and my algebra buddies. We were talking about like lines and stuff, and one of the things that we were just practicing and analyzing was the idea of steepness of lines, and a little bit of the language, perhaps, of slope was showing up. And so here is a mathematical definition of slope. The slope, m, that's also perhaps weird. You're thinking, why did they make slope m instead of s? But the variable s is usually reserved for the side length of a square. But m, if you think about it, is like a mountain. Mountains have slope. Problem solved. So the slope of a non-vertical line, so can't be vertical, passing through 2 points, and then they've got 2 points. The first point's coordinate for x, and the first point's coordinate for y, x1, y1, and then x2, y2, is the ratio of the rise to the run. Rise to run. All right? So I don't like the fact that they did the horizontal first. I'm going to think about it as rise to run, okay? Rise, run. What we see is one of the ways we can describe slope. So it's a ratio, and there are points in between there, but we can use this ratio to go up and over and up and over again, and that would land on another point on the line, etc. And I could just repeat that over and over and keep landing on points on the line. So my slope is represented by a fraction representing the rise to the run. And they say that the rise you could think of is the change in the y-coordinate. Notice that it went from y1 to y2 here, and that's the difference between them, okay? So that's the change in the y over the change in the x. It went from x1 here, x1, all the way to x2. And so the change in those things you could think of as being the difference between their coordinates. So if I, for instance, wanted to know when I hiked a mountain, if I started at 2,000 feet and at the end of the day got to 4,000 feet, what was my change in elevation? I would do 4,000 minus 1,000, right? I subtract those things to be able to figure that out. So that's how we end up finding the rise and the run, and the slope will be the ratio of those things. Also, we typically always run to the right, just like Mario usually does. You know, sometimes there's those sneaky levels where you can go to the left. Usually Mario's always running to the right. You know what I'm saying? You know what I'm saying. And rise will be positive whenever we're going up, and negative whenever we're going down, right? That seems to make sense. So when the line rises from left to right, the slope is positive. And when the line falls from left to right, the slope is negative. All right, so let's talk about how do I find the slope. Also, oh, here's a formula right there. Some might call that the slope formula, and you should probably eventually memorize that. So let's find the slope of these lines in example 1, and I'll show you a couple ways to do it. So first of all, let's do it off of the graph. Weird. So here's 2 points. So if I want to find the rise, how high up is this going? Like 4, and what's my run, son? 6. So my slope, I could think of as rise over run. And I'm not going to leave it as 4/6 because I can reduce that fraction. 2/3, yeah, 2/3 would be a better way to describe that slope, a fully reduced fraction. And the fact that I could reduce that, that means my slope was not just up 4/6, but I also could have done up 2 and over 3. And notice that I also would have landed at a point on the line. That's crazy. Crazy, friend. So the slope would be 2/3. Let's do the slope using the slope formula. So here, if this is x1, y1, and this is x2, y2, my slope formula is, I'll write it down again. Just because it's so easy to mix these up. And it doesn't matter which point you call point 1 or point 2, but once you do, you gotta commit, friends. You can't just like keep when half of them were point 1. Yeah. You gotta keep the y1 and the x1 together once you've called it that. So the slope here, so y2 is 2 minus y1 is negative 2, so 2 minus negative 2 over x2 is 3 minus x1 is negative 3. Right, it is easier to read it off the graph, but sometimes we'll be finding slopes without the visual graph already done for it. Yeah. I don't mind at all. 2 minus a negative 2 is the same as 2 plus 2, so that's 4. 3 minus a negative 3 is the same as 3 plus 3, which is 6. And then that reduces once again to 2. So my slope m is equal to 2/3. Question, is this slope positive or negative? Well, it's positive because notice that the value itself here is positive. Also, notice that it's going up as we move to the right. If Mario's moving to the right and he's going uphill, that slope is positive. If Mario's moving to the right and he's going downhill, that slope is negative. All right, let's figure out the slope for this one. So between these points, I'm going down 3. That's negative 3 units over 2. So my slope is negative 3/2. So that is the slope here. Now, as far as the points that I'm picking, I'm always going to compare 2 points that cross the grid exactly. All right, so notice I could have picked this point or this point or this point, but points that I wouldn't want to find slope from are this one. That's not super bright. Come on, let's get that brightness all the way. There we go. Right, I wouldn't have picked this point or this point. Right, why don't I like those points? They're points on the line, but for finding slope, they're landing on like the coordinates here are like -1, -3 or something weird. Like, I don't want to work with weird numbers when trying to figure out my slope. I want to work with whole numbers. And so when doing so, I'm going to always choose points that land on the grid exactly, right on those crosshairs, as you see here, right, or here, or here. All right, so even over here, I wouldn't pick this point or this point or this point, right? I don't like those points because they don't land right on the grid. Oh, but I could have picked this point, like that lands on the grid. And notice this went down 3 over 2. Watch this, down 3 over 2 again. Lands on the same spot, friend. That's right. Let's do the slope formula for this one. M equals, let's label our points, x1, y1, and x2, y2. Let's actually have you guys figure out the slope using the slope formula. I just labeled our points. I'll walk around and help internet friends hang out for a minute. And then once you see my mouse start moving, you'll know I'm back. All right, let's plug it into the formula, guys. Y2. What's Y2? False. -1. Y2 minus Y1. What's Y1? Over X2. 2. Minus X1. 0. Y2 minus Y1 over X2 minus X1. They're not. Because remember, it's the change in Y over the change in X. To find the change in Y, I'm subtracting Y's. What's up? Done. All right, so that's how I could find the slope algebraically. Perfect. Ooh, yes, it could be. Okay. All right, let's have you guys try these two problems then. Yeah, use rise over run off of the graph as well as the slope formula. I'll be around to help. Have a cough drop. Let's call this point 1. X1, Y1. We'll call this point 2. X2, Y2. Plug it in. All right, internet friends, Mr. Waddy is back. It's been a while. Yeah, or they scrub through the video until they see the mouse moving. See, look, now the mouse is moving. They know that I'm back. So let's see. M equals y2 minus y1 over x2 minus x1. Careful of that double negative. So 1 minus 3 is -2, and 1 minus -4 is +5 because that's plus. So -2/5. Now, if I did that same problem using rise over run, here's a point. That's a lattice point. It's on the grid. Lattice is called. To get from this height to that height, where do I go? I'm going down 2, right? And I get the same thing, m equals down 2 over 5. Now, not necessarily. So, guys, get with me here. We're talking. We're getting distracted. All right, let's do this one using the graph first, and then I'll do the formula. So I could use this point or this point, but I also see that this point would work. Trinley, why do I like this point? I like this point. Why? And I don't like this point. Because it's right on the grid, right on those crosshairs. So to do rise over run, I could have gone all the way up 4 over 6. I went up 4 units to get to the height of this. So I could have done m equals 4/6, which reduces to 2/3. Or if I picked this point and one of the others, let's actually go from this one to this one. I would have gone up 2 and over 3, and that would have fast-tracked me right to that without having to reduce fraction. Okay. Let's try using the formula. x1, y1, x2, y2. Well, you got to know both ways, friends. So let's see. y2, 3, minus y1 is -1, over x2 is 3, minus x1 is -3. Nope. But once you pick, you stick with it. So 3 minus -1 is the same as 3 plus 1. That's 4. 3 minus -3 is the same as 3 plus 3. That's 6. And that once again reduces to 2. All right, so we can find the slope using the formula or reading it off of the graph by figuring out rise and run. All right, what if I gave you a table? So here's example 2. So this is a little bit of a pain because we don't have a graph to go off of. Technically, I could call this x1 and this y1, and then any of the other points x2, y2. All right, I could combine any combination of these and find the slope between those points using slope formula. Okay. The other way I could do it is by looking at the changes in y's. So what's happening to the y's here? -6, and this was +3. So my slope was going down 6, it's the change in y first, over 3. And what's that reduced to? -2, and if it helps, you can write that over 1 so that you remember you're dropping 2, moving over 1. And notice, in this case, they had these equally spaced, so I could have done the same thing each time. And you guys would have told me a couple sections ago that this was a linear function because it had a constant rate of change, right? It was constantly moving down 6 over. All right, how about for this one? What's happening here for the y's? All right. Yeah. So my slope is 0 divided by 2. If I have 0 pizza that I'm sharing with 2 of my friends, how much pizza do they each get? They get 0 pizza. Yeah, that's sad. All right. How about, for example, C? This one's tricky. Look out. This one's going up 3s. Then this one up 6. And then this one went up 3. Doesn't matter, though, because in this case, this shows up over here. This one didn't change any. This was always 0. Almost. So let's just look at between these 2 points. It's going up 3 and over 0. If I have 3 pizzas to share amongst my 0 friends, each of my 0 friends is getting infinitely many pizzas? This is undefined. All right, undefined. You have, if you divide by 0, you can't divide by 0, so that's undefined. This we could call no slope. All right, no slope would be the situation. That's when the line is a vertical line. Actually, we'll even write that down. This was a vertical line. And yeah, it does. I was thinking of changing, and then I was like, I'm going to live with that. Look at you. And this is a horizontal line. So guys, 0 slope is a horizontal line, and no slope or undefined slope is a vertical line. All right, I'm fine with that. And let's see, so the last thing we're ending with today is this little table, which summarizes the following. Yeah, we will do that, but our internet friends, marble slides, okay? We're ending the lesson with them. I didn't want them to feel like they missed out of the fun that you guys have. Yeah. Shh, I'm whispering into the mic so they don't hear me. So guys, here's just a summary of some of the things that we'd learned today. Slope is the change in y over the change in x. A positive slope goes up as Mario runs to the right. A negative slope goes down as Mario runs to the right. He's running downhill. Slope of 0. And then it's just gonna be horizontal. It's not going up or down. It's changing by 0. And an undefined slope is not a function. It's a vertical line. You could also call that no slope. And that's just a cliff. That's a cliff. That's how you get to rock bottom from bikini bottom. All right. Thanks for watching, internet friends. Have a great day.